So anyway, that's why we represent it as a control source, or we will have to call it just an operational amplifier with a unique characteristic. Also, if the current is 0 here, it means that this plus this should be 0, because at this node you have to follow or Kirchhoff's laws. And that's what I have done in here. Based on that concept, develop the differential equation of the electronics part. And then this is the bond graph model of that. And what I have done in the write-up is give you a little demonstration as to how, using the bond graph variables, we can also produce the same equation as in 1, 2, which is the equation up here, C1, 2. Okay, now this is the piezoelectric transformation, is a transformation that occurs between the mechanical side and the electrical side. We can go back here for a second. You see, this is here's where what I would say is where it is rather, the piezoelectric transformation. So I say piezoelectric transformation. And that one you could represent as a TF element, where on this side you have on this side we have the force, which is over here, and the velocity, and then in here you have this piezoelectric transformation, and out here you will have a voltage and a current. You see, this is what the piezoelectric transformation does. Okay, so
yeah, before you erase that slide, would you just give me control of the computer so I can start my program for the screenshot?
okay,
just at some
okay,
point, whenever you think that's
okay, just for a second here. Yeah?
I think you got to control that.
Okay.
I just need it for 1 second.
How is that? Yeah?
Just about.
Okay. Yeah? Okay, we had a little interruption here, but we will
Yeah, I'm good.
okay. All right. So we'll continue with this. So now you have the mechanical model on this side. Now you see this is the mass and this is the ground in here. And we have done this model many times. And so you can see now we need to mix both of these. This is the little simplification of this, and that's the piezo. What do you need to do? You need to obtain the state space equations in form, and also find this transfer function. I gave you the idea, this concept of the transfer function Today we'll do a very detailed example on that to illustrate that some more. And here you have I would like you to assemble the electromechanical system, enter the bond graph model and generate the equations, all with a program, symbolically and numerically, and find out step and impulse response using MATLAB. Then on number 7 it says perform a simulation using the state space form produced by CamG and Simulink. This is a block that actually contains the matrices, and Simulink can analyze that. So this means to transform the state space representation into a block diagram and perform the simulations, compare the results, and demonstrate they are the same. And then perform the simulation using the transfer function that CamG will generate for you. Okay, so that is the what we need to focus next is into producing this transfer function. And so we'll take that was going to be our next explanation. So why don't we stop this one for now, and we'll start